Mote, Model Training Environment. Abstract, data is the lifeblood of all businesses. Data-driven decisions make the difference between leading with the competition or fall down. Machine learning is the key to unbolting the values of companies' and customers' data and approving decisions that keep a company ahead in the race. The conception of the model training environment is to make an interactive, visual workspace to easily build, test, and iterate on a predictive analysis model. The user can deploy a machine learning model without writing a single line of coding. The testing and training for the model are done on the same dataset. One can also summarize the dataset using a correlation matrix which helps to summarize the data and tells the relationship between the features of the data in the form of a matrix. Consequently, a pickle file for the trained model can be made to allow the user to use the implemented machine learning model anytime. Anyone who has little or no knowledge of machine learning can use the system for implementing and creating machine learning models without any hassle of programming being needed. Keyword Web Interface, Model Training, Machine Learning, Supervised Learning, Machine Learning Algorithms. 1. Introduction. The basic idea behind model training environment is to make a visual workspace where one can implement and visualize machine learning algorithms without writing a single line of code. Through this project, we want to ease the implementation of machine learning models using machine learning, Django, and React. The system initially consists of uploading the structured dataset which is stored in the database. The corresponding dataset is converted into a data frame on which the operations are performed. A Pandas library is used for the conversion into the data frame. Real-world data generally contains noise, missing values, and may be in an unusable format which cannot be directly used for machine learning models. The probability of exceptional data has increased in today's data due to its colossal size and its start for diverse sources. Data pre-processing is the step in which the data gets transformed, to bring it to such a state that now the machine can easily parse it. In other words, the features of the data can now be easily interpreted by the algorithm. Data pre-processing is required for cleaning the data and making it suitable for a machine learning model, which also increases the accuracy and efficiency of the machine learning model. It involves feature encoding, which is basically performing transformations on the data such that it can be easily accepted as input for machine learning algorithms while keeping its meaning intact. Basically, we are applying 3 techniques: scaling, one-hot encoding, and imputation. Scaling is applied to independent variables or features of data. It is done to transform the data features into a specific scale like 0 to 1. It standardizes features by removing the mean and scaling to unit variance. The standard score of sample X is calculated as Z equals XU/S. Now, one-hot encoding is applied for feeding categorical data to many scikit-learn estimators, notably linear models and SVMs with the standard kernels 31. This creates a binary queue for each category and returns a special form of matrix. We apply the one-hot encoding on the categorical features to convert them into integer values. The data may also have some missing values, which are handled by the imputation transformer. The imputation strategies mean, median, most frequent, and constant are used according to the data. A correlation matrix, which is a table showing correlation coefficients between variables, will be plotted 10. The correlation matrix may help to know the required labels 9. It is a way to summarize the data and helps to understand the relationship and dependence among the features of the dataset. After the data pre-processing phase comes the algorithm selection phase that involves the implementation of various machine learning algorithms, both classification and regression. These algorithms are coded using scikit-learn library. Whenever the user selects the algorithm, the code for that algorithm runs on top of the user-given dataset in the Django backend, then it renders the result on the web interface in the form of predicted score. 2. Related work. Machine learning, due to its vast possibilities and demanding global market, has become a key of interest for innovation, research, and design. Presently, there are several online platforms that can help in the ease implementation of machine learning algorithms. But these systems have their own shortcomings and they are not fully able to utilize the architecture and resources, such as lack of centralization, dependency on the operating system, and lack of user-friendly interface. In our system, we have tried to overcome the above by uploading the dataset on our database, making the computation depend only on the server rather than operating system and a user interface system. In this section, we will be discussing some innovative machine learning platforms. An online machine learning platform is developed by Google known as Google Colab. It is a free cloud service and provides a free GPU. The hassle of creating a local environment with Anaconda and installing packages is eliminated by Collaboratory. Colab solely works on Google Drive and comes with a lot of Python libraries. But it has some shortcomings, like one needs to install specific libraries that do not come with standard Python for every session. Also, Google Drive is our source and target for storage, which makes it eat bandwidth for large datasets. 5. Colab allows one to work on the system without interruptions, but not more than that. Google Storage is used with the current session, so if someone has downloaded some files and wants to use it later, it must be saved before closing the session. The online workspace developed by Microsoft known as Azure Machine Learning 7 is a better option that eliminates the coding section. It uses best-in-class algorithms and a simple drag-and-drop interface which allows deployment in a matter of clicks, and it accelerates model creation with the automated machine learning user interface access, built-in feature engineering, algorithm selection, and hyperparameter sweeping to develop highly accurate models. 33. It is a secure, trusted platform and designed for responsible AI. It has the support of open-source frameworks and libraries including Kubeflow, MLflow, TensorFlow, PyTorch, Python, and R. It build machine learning models using enterprise-grade security, compliance, and virtual network support of Azure. It is an end-to-end machine learning lifecycle support.